Okay, relative velocity video. You're going to need this paper, and this was the practice worksheet. This one needs to be cut, all dotted lines, so you end up with 4 boxes like this. If you need to, pause at this time to get that cut. Okay? Alright, so velocity. Let's talk about velocity. Velocity. Definition of velocity, well, velocity is speed with one specific added detail, the direction. So how fast you're going and what direction you're going. That's velocity. Now normally speaking, speed and velocity pretty much the same thing. Rarely do you need to actually distinguish what direction an object's moving. So usually speed and velocity are pretty much the same idea. But when we're talking about relative velocity, the direction is vital. Okay? So to build up to the concept of relative velocity, we have a few of the concepts I want to cover. So find this picture, find this one, this box. I'm going to fold on the dotted line. What you're looking there is a radar gun, like the police use to measure a person's speed if they're going over the speed limit. Okay? So right there. This right here, the velocity in a split second, that is a description of instantaneous velocity. So on the back side of the paper, write down instantaneous velocity. Instantaneous velocity. Okay? Just a little bit of terminology here. Instantaneous velocity is the snapshot of velocity. If you could take a picture. Okay? The velocity before and after that moment doesn't matter. So the example is the police speed gun. So imagine you're driving, you're going over the speed limit, and up ahead you see a cop. Your automatic reaction is to slam on the brakes and look down and see how fast you're going. Okay? For the cop, he doesn't care how fast you're going before. He doesn't care how fast you're going 2 seconds later after you've slammed on the brakes. All he cares about is what the gun said at the moment that he tagged you. Okay? So that is instantaneous velocity. Go and take some glue, just a little bit. Glue that down. Go and put a little note next to it. Okay? Instantaneous velocity is speed and direction at the exact moment. Okay? So imagine you're doing some sort of lab or activity and you're measuring an object with a stopwatch. So example of instantaneous velocity would say that the car is moving 2 meters per second south. Okay, that direction there's the south. At a time of 4 seconds. So when the stopwatch said 4 seconds, it was going 2 meters per second. Okay, that's an example of instantaneous velocity. Next concept, this one has the road and the trees on it. Okay, fold again on the solid line. It says the speed and direction do not change. If your speed and your direction do not change. Okay? If you put the car on cruise control while driving down a perfectly straight road, that is an example of a constant velocity. A constant velocity, that speed doesn't change. So the cruise control little button on your car that controls the gas pedal for you if you're going to be driving, usually like on the interstate, not going to be slowing down or speeding up. And then perfectly straight road, no turning, changing direction. If you have those two factors together, you have constant velocity. Okay? The speed and the direction do not change. Now this doesn't actually happen very often in real life. Okay? Because very few roads are perfectly straight, and it's not very often you can actually put it on cruise control because there's traffic and other things and slowing down and speeding up. Okay? So, a little mental thing that I like to do to remember this one is the idea of just keep going, and going and going and going, and just keep going. Okay, that's constant velocity. All right, find the box that has the map. Fold that one in half. Okay, when you consider a whole trip, it's the usual speed and general direction traveled. This is what we call average velocity. Average velocity is a more realistic measurement of velocity. Okay, instantaneous velocity is what like the cops care about. Constant velocity doesn't happen very often. It's more of a conceptual thing. Average velocity. Okay, average velocity, you take into consideration the whole trip. How far did you go, and how long did it take you to do the trip? Rarely is that, you're never going to have a perfectly constant velocity during an entire trip. So it's taking the whole thing into consideration. Okay? And this one uses the formula velocity as displacement over time. So the overall trip. So the typical speed and direction for the entire trip. Now the reason why I chose the picture of the map, look, find Laredo right there at the bottom. Point an arrow at San Antonio. Okay? North, south, east, and west. Okay, a little compass rose there. To get from Laredo to San Antonio, you have to go northeast. Okay? And if I was going to describe my velocity to get there, so my example, all right, 75 miles per hour northeast. All right, 75 miles per hour northeast. That would be an example of an average velocity to get to San Antonio from Laredo. All right, average velocity. Now our last little paper, one of 3 stick man on it, that is relative velocity. Relative velocity has to do with where you are positioned and where I should rephrase that, the velocity of 2 objects relative to each other. Okay? It's dependent upon the frame of reference or reference point. So you need to consider the velocity of both objects when you're doing this. So ultimately, the motion is based upon your reference point. Okay? Motion based upon reference point. Now, a little note here. It says here, positive one is one direction and negative is the opposite direction. With relative velocity, the direction you're going really is very important. So, generally speaking, in physics, if something is going up, we make that a positive value. If something is going down, we make that a negative value. Okay? Likewise, if something's going to the right, we call that positive. We give it a positive value. If something's going to the left, we give that a negative value. The most important thing here is simply that opposite directions have positive and negative values. Okay? And that helps us to be able to calculate when we're dealing with relative velocity. And that is the journal entry.